So the purpose of this video is to show you how to correctly make a graph using Google Sheets, but this also applies if you use Microsoft Excel. So when you are doing an impeccable lab investigation write-up, sometimes you need to insert a graph. You didn't need to during the egg lab, but since we're dealing with uncertainties, this is a good time to show you how to create a good graph in Excel, showing the correct labels and where to put the uncertainties in your graph. So I have some data here that I collected the summer before last during the total solar eclipse. And yes, I did sit out on my front porch for 45 minutes and recorded the temperature in 3-minute increments to see how the temperature decreased as the sun increased its coverage. So that's what science teachers do for fun. So what I've got going on here is time, the time I had on my clock, what number of minutes I was registering while I was gathering the time. So I started collecting my time measurements at 9:44, and then I collected another one 8 minutes later, but then I went up in 3-minute increments after that. And then what I've got here is the temperature in Fahrenheit and the temperature in Celsius. So before I get started making a graph out of this to find a relationship between time versus temperature, I am going to make sure my sig figs are correct and I have listed the correct number of in certain digits. I was using a digital thermometer when I performed this task. So my last decimal place is in the 10th spot. So I'm going to say here plus or minus 0.1. And I don't have to put the degrees Fahrenheit after there. And then I transferred that into Celsius because the correct SI units for temperature is Celsius, and I have 0.1 here as well. I like to make sure my labels are correct before I make my graph, because then Google will auto-copy those labels for you. So I would like to make a graph showing the relationship between temperature versus time. I'm not going to use the clock time over here. I am going to use the minutes measured. So what I'm going to do is I'm going to highlight that whole first or second, third, and fourth column there. And I'm going to go to Insert, and I am going to go to Chart. And it's going to give me a bunch of options. I do not want a bar graph. Bar graphs do not interest me. In fact, in physics, we will be using scatter plots 99.99% of the time, because scatter plots are a good way to show the relationship between variables. So I scroll down and find scatter plot, and I notice here that I have on my x-axis temperature measured, and in my y-axis I actually have two of them. I have the Fahrenheit temperature and the Celsius temperature. Since I really don't care about the Fahrenheit one, I can click on that and remove, and notice that now I'm just left with minutes measured versus temperature. Since I'm right here right now, I can go ahead and go to Customize, and I can start adding some titles. So I'd like to teach you something called tails. Title, axes, increments, labels, scales. In fact, I will go down here and I will type that for you. Labels, scales. These are all the things that you need to have in a correct scientific graph. The title has to be a certain way. And to get back into my graph, all I have to do is right click, which is on the Chromebooks, Alt, and then click your keyboard. And then I can go to Chart and Axes Titles, Chart Title, and there's unfortunately no creativity with this. When you're using a graph in a physics lab, you have to say y-axis versus x-axis. So I'm going to say here, temperature outside temperature outside in Celsius plus or minus 0.1 versus my x-axis, which is time in minutes plus or minus 1. Now I've got a correct scientific title here, temperature outside Celsius plus or minus 0.1 versus time, units, minutes, with an uncertainty of plus or minus 1. So yes, you have to put your units and uncertainties here as well. And remember that this is going to go y versus x. The axes have to be labeled as well with the units and the uncertainties. And so the horizontal axis title, which is your x-axis, is going to be time in minutes plus minus 1. And then to change to your vertical, you click on the same spot and say vertical. And you say here temperature in Celsius, a parenthesis, Celsius plus minus 0.1. Now your labels are correct. Your axes have to exist. You have to have an X and Y axis. And so Google does that for you. Your increments have to be equally spaced, which they are. Google has chosen for you an increment of going up by 10-minute increments on the X and 0.5 increments in temperature on the Y. Your labels have to be correct. So your labels here, your x-axis is labeled with the variable, the units, and the uncertainties. Variable, units, and uncertainties. And your scale. Your scale, again, is equally spaced, making sure that every place in between these increments has the same amount of space, but Google does that for you. So one of the nice things about using tails, which is the scientific way of graphing, is that Google Sheets does most of that for you. So now the last thing I want to show you is how to do a line of best fit, or a trend line. And a trend line tells you the mathematical relationship between the y versus x variable. So I'm going to re-click onto my chart, and I'm going to go to series and choose on temperature again. And I will notice this piece right here. I would like to choose data or trend lines and data labels. So I'm going to choose trend lines. And I'm thinking when I do a trend line that is linear, that line is really close to all of my data points on my graph. So I think it's pretty much a linear relationship between temperature drop to time when the solar eclipse is occurring, which when I did this at home, I was kind of excited about it, of how linear it was. I can choose a color for my line. I can be creative. I like that color. I can choose how thick my line is going to be. This is where you can kind of be creative. Now, one really important piece here is the label. And the label is where you get the actual mathematical relationship between your y versus x variable. So I click use equation and show r squared value. So when I'm looking at this here, I notice that I now have a slope-intercept form function that describes the relationship between my y versus x variable. So my slope of my line is telling me that my change in temperature decreases 0.04 degrees Celsius for every 3 minutes, or for every minute, give or take. My starting temperature was 19.6 degrees Celsius, give or take. And now this R² value. So when you take statistics, you will know how to calculate an R² value. But for physics purposes, all you need to know about R² is the closer it is to 1, the better your trend line fits all of your data. So I consider this like 0.985 or 98.5% on my trend line. That is a really good linear relationship. That's telling me that basically, in essence, 98.5% of all of my data falls on my trend line. So I can make a really good conjecture that my temperature versus time relationship is linear. So that is how to make a really good graph in a physics or any science class. You can be creative with this. You can change the background, you can change the font and all of that stuff, as long as you have the following tails components. Title, which is going to be y versus x with units and uncertainties. Axes, x and a y axes. Your increments are there, equally spaced, which also goes to scales. And your labels are correct on your x and y axis. And then you need a trend line as well to show the relationship between your y and your x variable. So you can rewind this video as you see fit, and hopefully this will help you practice with my data sets that I've provided you on Schoology. Have a lovely day.